All right, if you've been watching the AI space lately, you've absolutely heard the term AI agents thrown around everywhere. But, there is a massive gap between just chatting back and forth with an AI and actually building an autonomous, reliable agent from the ground up. So today, in this explainer, we're diving into a clear 10-step blueprint to figure out exactly how to build one. We all know the problem here, right? You ask a large language model to do something complex, and the output is often just chaos. You get unstructured text, totally forgotten instructions, and basically a complete inability to string together multiple steps reliably. So, how do you build an AI agent without all that mess? Well, you don't treat it like a magic 8-ball. You have to treat it like a system. What we're doing today is walking through a reliable blueprint to take back control so we can turn those unpredictable text generators into precise digital workers. Let's just dive right into this master map. Here is the complete 10-step blueprint we're going to conquer today. Now, looking at it all at once, yeah, it might seem like a lot. But the secret is to think about building an AI agent exactly like hiring and onboarding a brand new human employee. You wouldn't just sit a new hire at a desk and say, okay, do business. No, you define their role, you give them tools, set up their computer, introduce them to the team, and review their work. We're going to do exactly that, step by step, for our new digital employee. To make sure we avoid cognitive overload, we've grouped these steps into 5 digestible phases: setting the foundation, adding logic and tools, memory and multi-agent teams, senses, interface and delivery, and finally, evaluate and monitor. Let's get started.
Phase 1. Setting the foundation. This is where we define the role and goal.
This first phase is really about forcing us to shift our mindset away from basic chatbots. Step 1 is defining the agent's role and goal. What exactly is it going to do? Let's take the example of a medical assistant agent. Its job isn't to just casually chat. Its job is to specifically read X-rays, summarize the findings, and deliver those results. Once we know the job, we move to step 2, design structured input and output. This is absolutely crucial. You have to avoid messy text. You need the agent to think like an API. You define exactly what data it receives and exactly what it returns, and you usually do this using JSON schemas. Then, in step 3, we tune behavior and add protocol. This means setting up strict role-based system prompts so the agent never breaks character or steps outside its assigned duties. And to actually build this foundation, you aren't starting from scratch. The blueprint highlights some very specific tools here. For designing those structured inputs and outputs, you can use Pydantic AI or LangChain output parsers right alongside your JSON schemas. When it comes to tuning behavior, you're leveraging powerful core models. Think GPT-4 or Claude, and using prompt tuning. And I really want to highlight MCP here, the Model Context Protocol. Think of MCP as a universal translator. It standardizes how your agents operate and communicate from day one, so things don't just randomly break down the line.
Moving on to phase 2, adding logic and tools. Let's give this agent a brain.
If phase 1 was giving our employee a job description, this phase is giving them a logical brain and a physical toolbox to actually do the work. Step 4 is where we add the React framework. You don't just want an agent that wildly guesses, you want one that thinks. React literally stands for reasoning plus action. It forces the agent to use a chain of thought. So it talks to itself, saying, okay, I need to do X, therefore I'll use tool Y, and based on what that gives me, I will do Z. It's systematically thinking through problems before taking a single action. And what exactly are those actions? Well, that's where external tools come in. Remember, a base language model is effectively trapped inside a box of its own training data. By giving it tools, we allow it to interact with the outside world. As we can see, we can give our agent access to web search for real-time info, code interpreters to run math and scripts, or document retrievers to dig through your private files. You connect these using toolsets from LangChain or OpenAI tools, and just like that, your agent suddenly has hands.
All right, phase 3, memory and multi-agent teams. Time to scale up. Sometimes a task is simply too big for one single agent to handle. We need to add coworkers for collaboration and a massive filing cabinet for long-term project context. Step 5 is structuring multi-agent logic. If your task is super complex, you break it down and assign it to a team, acting almost like a digital assembly line. You might create specific roles, like a planner agent, a researcher, and a reporter. Each one has its own specific input and output schema, smoothly passing the work down the line. Then we hit step 6, adding memory and long-term context. Think about it. If your agent is working on a month-long project, does it need to remember what happened on day 1? Absolutely. Otherwise, it's starting from scratch every single time you talk to it. So how do we solve that memory problem? The secret sauce is RAG, or Retrieval Augmented Generation. This is how you give your agent long-term context.
Depending on what you actually need, you might use conversational memory for running chat history, summary memory to keep a condensed version of past events, or vector-based memory to instantly recall specific facts hidden across thousands of past documents. Tools like Zep, ChromaDB, and Fize basically serve as that permanent filing cabinet for your agent's brain. Now, to coordinate these complex multi-agent teams so they don't constantly step on each other's toes, you're going to want to use an orchestration framework. You definitely don't have to code the management structure from scratch. Instead, use frameworks specifically designed to define these roles and coordinate them, like CrewAI, LangGraph, or OpenAI Swarm.
Phase 4. Senses, Interface, and Delivery, bringing the agent to life. Okay, so our employee is brilliant, they're well-equipped, and they have a fantastic memory, but right now, they are trapped inside a command line terminal. It's time to give them eyes, ears, polished presentation style, and a proper front-end office. Step 7 is technically optional, but it is highly impactful. Add voice or vision capabilities. You can literally let your agent see and speak. Step 8 is where we ensure the output is actually useful. You need to format the outputs into Markdown for clean PDFs, or maybe strict JSON. The output has to be completely readable by whatever system is receiving it. Finally, step 9, wrap and a UI. Creating a front-end interface takes your raw and visible script and turns it into a tangible product that a user can actually, interact with.
To achieve this final layer of polish, there are some fantastic tools out there. For text-to-speech, giving your agent a voice, you can use Koki or 11 Labs. For image understanding, giving your agent eyes, you can utilize GPT-4o or Llama 3.2 Vision. And for that Step 9 UI wrapper, you can quickly build a great front end using Gradio, Streamlit, or FastAPI.
And our final phase, Phase 5, Evaluate and Monitor.
We've officially built the agent, but don't walk away just yet. Think of this final step as the rigorous employee performance review. Why? Because an unmonitored AI agent will start slacking off or hallucinating faster than a human employee on a Friday afternoon. Step 10 emphasizes that you absolutely must run test prompts and test your toolchains to check for reliability. You cannot just assume the agent is going to do it perfectly every time. You have to use logs, run benchmarks against expected outcomes, and collect user feedback to continuously improve the agent. To properly monitor and evaluate, you need the right instruments on your dashboard. You should be utilizing MCP logs to see exactly how your standardized models are behaving under the hood, the OpenAI Evaluation API to automatically score your outputs, or even building custom metrics dashboards to track the exact KPIs that actually matter for your specific agent's job.
And there you have it. That is the complete 10-step blueprint to take an AI agent from a chaotic idea to a structured, highly reliable product. We defined the role, we structured the logic, added memory, gave it senses, and locked in a monitoring system. The framework is literally right here waiting for you. So I'll leave you with this final thought. Now that you have the map, what role will your very first custom AI agent play? Thanks for joining me on this explainer, and happy building!